So this week we welcome to the Nutshell Savita Nutan. Savita is a university degree course leader, a former scientist, and a passionate advocate for animal-free medical research. She is the founder of Medicine Without Cruelty, which is an educational organisation dedicated to promoting medical research without animal cruelty. So welcome to the Nutshell, Savita.
Oh, thank you very much. Thank you, Claire.
So it's lovely to see you. You have actually got a very interesting career path, which is what led you to work in particular on campaigning against vivisection. So that's our first question. Can you tell us more about that?
When I left my career in the sciences, I still remember it. My manager told me at that time, it will cost you. Every time you change careers, it will cost you. At the time, I was working as a research fellow in genetics research. And for a while, those words haunted me because I just thought to myself, was I making a mistake? Was I throwing away years of study and hard work? Because I had trained in molecular genetics. I had done postgraduate degree specializing in clinical sciences. And then I did an NHS training program to become a healthcare scientist, as it's called now, and working in a diagnostic hospital laboratory. So it was a lot to throw away, almost a decade of studying and hard work to get where I was. But, deep down, I knew that I wasn't in the right place. And, I'd spent most of my life believing through all that study and work that animal testing was some sort of necessary evil, that it was the only way to develop treatments for human diseases. But when I found myself working in a laboratory, and it was not the laboratory itself, it was working in that whole environment where you would be listening to work being done on animals and you'd be questioning why is this correct? I couldn't shake that feeling that something wasn't right. It wasn't just discomfort. It was being fundamentally opposed to what I was doing. And it was through understanding the science and truly understanding that what is human is truly human. And we cannot be using an animal to replicate that. And so I walked away. I left behind that traditional path of medical research, and I had to set out to find a career that aligned with my values. And what I discovered was a whole world of scientists and researchers working on cutting edge alternatives to animal testing. Methods that don't simply replace animal experiments, but actually offer reliable, human relevant results, which animal methods just don't do. And we have these technologies, such as organ on chip, 3D printed human tissues from the very start. It's not science fiction we're talking about. They're real. They're happening now. And they're proving to be effective. And what we have at the moment in research, that current environment, is completely outdated, is completely unreliable, and shockingly cruel. The more I looked into it, the more I realized that the UK still pours millions into animal-based research, despite overwhelming evidence that it's just not working. There are drugs that pass animal trials that quite often fail in humans, and quite often with devastating consequences. Take, I like to use a classic example such as Vioxx. It was tested on animals and tested on multiple species, deemed safe. And then it went on to cause approximately 140 to 150,000 deaths worldwide. And those numbers speak for themselves. What is it that's stopping change? Coming back to me in my career, I need to think about, how can I make a real difference? And I had to look at what actually brought me joy in my life. And the answer was clear. It was that I needed to educate. That every job I had involved teaching in some way, and I realized that that's where my strength lies, that I don't just want to inform people about science or do the science. I want to highlight all the amazing things that are happening currently in the world of non-animal methods and encourage students to think critically, to answer questions that I kind of wish that I could go back in time and have asked then and challenge the way things have been done. So here I am speaking about change and the need for it, for innovation, research that doesn't rely on outdated, unethical practice. To answer my old manager's question, changing careers did cost me, but staying in a job that went against everything I believed in would have cost me so much more. And, for anyone who's listening, if you're questioning your career path or you're involved in any way, shape, or form in something that you believe is unethical, such as animal testing, you need to find what truly aligns with your values. Find what makes you feel like you're making a difference, because when you do, that cost of change is nothing compared to the freedom of knowing that you are exactly where you're meant to be.
We've reflected there on the words of your manager, and you've obviously found a really good career in education. But to be fair to the other scientists out there, do you think that if they have got principles about not using experiments that involve animals, that are there ways for them to continue in research at the moment?
Absolutely. Absolutely. When I first left that career in science, I remember making a massive spreadsheet of all my skills. And when you've worked in a niche for so long, I looked back and I felt like, oh my God, it's completely useless outside my niche. But then as I reflected, I started to think about what are those skills that are transferable, and that's education. And for me personally, that's where it led me to where I am today. And have my principles limited the scientific work I can do? If you look at it in the traditional sense, if I wanted to go into particular medical genetics and looking at the laws that are currently here, fine, yes. Many laboratories still rely on animal experimentation, and that's a line that I will not ever cross. And I want to be part of a movement that creates more opportunities for students and colleagues and scientists in the sector to work in non-animal methods, and these cutting edge tools. Where the real innovation is happening is human relevant and evidence driven, and that's what's popular today. The future isn't simply just cruelty free, it's real science. So yeah, I think there's so much scope out there, and I don't think it's not about us limiting ourselves. It's about actually expanding our repertoire and reskilling ourselves to all the techniques that are completely cruelty free.
So just before we go into a bit more about what the current problem is, part of your career has been setting up this organisation, Medicine Without Cruelty, which obviously goes beyond educating. It's doing a bit more than that. So can you tell us about that now?
Sure, yes. So Medicine Without Cruelty was what I wanted to create to educate students of all ages. If you think about our relationship with animals, the very root of it starts in schools, how we relate to the natural environment and how we think of animals happens from that very root. I want Medicine Without Cruelty to help students understand that animals are not an instrument for our use. They are not a tool for us to use. And that needs to happen at schools. And then, from that age into secondary school, it's about us thinking critically and providing methods that they can further. For example, AI is massive. If we can get students to understand how that can benefit scientific research and testing and regulatory testing, that could be amazing. And then again, with universities, what I'm doing at the moment is wanting to partner with companies that are completely cruelty free, because there are the pharma AI development, it's, billion-dollar companies out there. It's a massive area for students to move into. And I really do want to partner with companies that are promoting this. Hopefully further down the line, I could be able to provide work experience opportunities for our students. So that's kind of the main aspect of Medicine Without Cruelty, is providing curriculum development, alternative resources, encouraging people, let's not, within schools and colleges, let's not dissect. What can we provide that actually helps students understand the science? And then there's advocacy. I support campaigns all over the world. There are campaigns here in the UK, if you might have been aware of. There is the petition to ban dog testing here in the UK. I've been working with a group in Mauritius as well. So I don't know whether you're aware about the import of macaque monkeys. They are on the endangered list now because these primates have been exported to countries all over the world for testing. And this is where we need to make sure that our efforts are all aligned. And also working with other campaigners as well, because I fundamentally believe that all of our ways might be different, but we're all working towards the same goal, and we need to end animal testing. So yeah, so that's in a nutshell is what I'm doing. But yeah, everyone can definitely follow on social media and spread the word.
Brilliant. And we'll put all your links in the show notes, Savita. But before we go on to ask you a little bit about the details of the alternatives that you've already started to mention, can I just clarify the extent of the current problem? How many animals are being subject to testing currently?
So recent statistics indicate that in 2023, it was just under 3 million scientific procedures, or something like 2.7, that involved living animals that were conducted in Great Britain alone. It is still a huge number, but it's also showing us that there is a shift towards non-animal methods, because that point hasn't been under 3 million since the previous year. However, if you look at the dip overall, there was a slight dip over COVID, and has still kind of crept back up, not as much as we would have thought. Now, globally, the estimates across the world is almost 200 million. The use of animals in research varies significantly across countries, and we know that that's influenced by different factors, such as the money that goes into scientific infrastructure, the regulatory framework, so the laws that are in place. If there are stricter laws, that influences the entire nation. That's what we should be pushing towards, and ethical considerations. Now, for instance, like in 2020, the US utilized approximately 20 million animals in research and testing. And, we hope that that's a reliable statistic, making it the largest user globally. Now, if you think about other countries, I mentioned Mauritius, it uses comparatively fewer animals in domestic, so local research, but it plays this horrific but pivotal role within the international primate trade, because it's among the leading exporters of primates, particularly these macaque monkeys, because they're in high demand worldwide. So it's really important when we think about how animals are used globally. It's not just the amount that's used within a country for research purposes, but how significantly they can contribute through the export of these research animals. Now, I think that's why efforts need to be different, where it might be imploring policymakers in some countries, we need to be banning the development of these breeding facilities.
Yeah, so different countries might need different targeted interventions.
Absolutely.
That makes sense. I mean, the numbers are staggering, but just taking, say, like a drug development, do we know like what sorts of numbers of animals are required to develop just a drug, and do companies report on this, or is this not at all transparent?
That's a good question, because the number of animals used in developing a single drug varies significantly, and it's usually to do with the drug's nature, what the therapeutic area might be, and what the regulatory requirements are. Estimates suggest that around 5,000 animals are used to test each chemical, but that's an approximate value, and it can be up to 12,000 when it's needed for, say, pesticides. Now, you made a good point about transparency. Like pharmaceutical companies, they typically report on the total number of animals used in their research activities every year, but they don't disclose the specific number of animals used for individual drug development projects. Obtaining precise figures on the number of animal lives taken in a particular drug development is incredibly challenging. But it's really important nonetheless, and not just for drug development. I know we're talking here about mainly the health profession, but also when it comes to other toxicity testing, such as pesticides. I just wish we were more clear on that as well.
A lot of people listening will simply have an ethical position on animal testing, which would be independent of any arguments that someone could put forward about using animals to improve science. But if we could just take a step back and put the ethics to one side, what does the science say about how we can best move research forward? I know we've touched on this a little bit already, but I think what people are interested in is how we can really look at the arguments that say we don't have to use animals for testing, and what are the alternatives, and how could we get better outcomes if we do that?
Fundamentally, if we look at it from a scientific point of view, animals do not replicate human biology. And that's the long and short of it. My background's in genetics, and this is what I had come in complete odds with. We have understood the process of evolution, and we've understood that, yes, we have common ancestors to animals. A monkey might be, say, almost up to 95% similar to humans. But that remaining 5% has fundamental biological differences, meaning that it is a poor predictor of human responses. There are multiple studies out there, including even the NIH, that between 92 to 95% of drugs that prove safe and effective in animals then fail within human clinical trials. It was in 2004 when the FDA estimated that 92% of drugs that pass preclinical tests, so involving those animal tests, then fail to proceed to the market. And then, they did more recent analysis that percentage is now closer to 95, 96%. That despite efforts to improve the predictability of animal testing, that failure rate has simply gone up. The main causes of failure are due to the lack of effectiveness and safety problems that were just not predictable by animal tests. If it's unable to model human complexity, and we're unable to predict human responses, why are we still taking it this far down the road? We need to be thinking about how can we completely move forwards without animal testing. And that can be done with what's available at the moment. Now, in many ways, we have reliable, human relevant, scientifically advanced technology. For example, organ on a chip. And it's able to reliably predict the dynamics of an actual human organ within a microfluidics, a small chip. For example, we can have a liver on a chip, and there's been studies already where it's shown that a liver on a chip has outperformed traditional animal testing by predicting accurately the response to several different drugs, something that animal testing could not do. So we have this proven reliability. Also, stem cells are a massive area now as well. We can provide human stem cell derived differentiated cells that can be used in science. We already touched on AI and computer modeling, but these simulations can predict how a drug's going to behave in our body. Also, with organoids, we can create organ-like systems within a petri dish. We have a way of building that three-dimensional architecture within the laboratory, within controlled settings, that we do not need an animal for. So why are we still using animals? That's my question.
So an organoid is
Yes.
a replica of
an organ-like, yes.
Yeah. Okay.
Yeah.
So many questions, Savita. I want to go into a bit more detail about these alternatives, but
okay.
I think when people hear about the idea of something not being tested on animals first, I think in their mind they've got this idea that somehow by running an animal experiment, it's somehow saving humans from harm, even if it might be misleading us in terms of where the science is actually going. It's the kind of first step in something being safe. So are you sure that there are arguments against needing to do that, or are there any areas where the science is less clear?
Honestly, there is no benefit to using animals, and this is whether you view it from an ethical standpoint or a scientific. There was a notable review. It was published in 2007, and they compared animal experimentation results with clinical trial findings, and they used it across multiple different interventions. They looked at the treatment of head injury, respiratory diseases, osteoporosis, stroke, hemorrhage, etc. And they found that human and animal results were in accordance only half of the time. So in other words, you could flip a coin. These animal experiments were no more likely than a flip of the coin to predict whether those interventions would benefit humans. Why are we accepting those odds is what I don't understand. If we can move forwards and actually use data that is scientifically sound and use methods that are scientifically sound, why aren't we? Because it's putting us at a disadvantage.
Okay, got it. So we've got organ on a chip, we've got artificial intelligence replicating systems there. And you've also said about stem cells. So I think I can grasp that. Is there anything else that we need to be thinking about in running experiments that wouldn't be on animals?
Omics is another area that I haven't spoken about, but it refers to a collection of disciplines within biology that study the characterization and quantification of biological molecules. We can talk about genomics being the structure, the function, and the mapping of human genes. Non-animal methods can use human cell cultures or tissues to study gene expression and therefore what mutations might be involved in diseases. As we understand human proteins, we can understand how proteins interact with each other, how they can be modified, and how they function without ever needing an animal in there. For example, we can think about how drug mechanisms work and how they will interact with, say, proteins from these organ-like organoids, human-derived organoids, and think about their toxic effects as well. We can think about the metabolites, and you might want to use, say, human cells to detect changes in metabolic pathways when you've exposed it to a particular substance. So when you're trying to understand the toxicity of something, you can study these metabolomic changes to predict whether or not you're going to have a toxic effect. So you might have an organ-like structure mimicking a human liver, and we can study what the metabolic processes are to predict whether or not this drug will have drug-induced liver injury, for example. So there are all these different ways that we can combine how we understand how living beings are structured, how they function, and how they are dynamic, and how that can help us to move forwards in a non-animal methods revolution.
So, Savita, the science sounds a bit too complex for my simple brain. But it's, from what you're telling me, it sounds like we could do a lot of what we're doing on a more cellular level, on a more petri dish type level. Is that correct? Is that what I'm understanding?
I think the simplest way to put it is, at the moment we are using, because it's a law requirement at the moment to use animals when it comes to the drug development process. We are putting a molecule in a black box that we don't understand whether the data coming out of it is reliable. And what we're seeing is notable instances where drugs have caused horrific injuries to human health. We have seen 95% of the tests that were presumably passing these animal tests to then go on and fail. And we're seeing that the comparison of human to animals only being in accordance about 50% of the time. So no more than flip of a coin. We are now moving on to understanding the very mechanism that drugs cause within us. Now we need to understand it's not a whole living being that we need to put it in that has some form of similarity to us. We need to be putting it in a human relevant application. And that means human cells, human tissues, being able to use artificial intelligence based on the data we have. And, we have so much health data available already. If we've worked in a hospital, how much data there is out there and how we can train these artificial intelligent systems to be able to predict whether or not a drug is going to work within us or not. So yes, it's simply put, it's a petri dish, but it's a petri dish of cells that are relevant. It could be even personalized to the patient itself, using a patient's own cells to predict whether or not they are going to successfully be treated.
And so, from a practical point of view, have we seen any changes recently within medical research to actually reduce animal suffering?
I think it's important to challenge the idea that the goal should simply be to reduce suffering, when we should be asking why we're using animals at all. I mean, the real progress in medical research is happening through human relevant non-animal methods, that it not only eliminates suffering, but we're also providing real scientific outcomes. Now, I mentioned earlier about the liver on a chip studies that provided accurate findings when it came to drug-induced liver injury. And so the focus should not be on making animal testing less painful. It should be on removing it entirely and us moving forwards. And I think there's one thing that I probably didn't mention earlier is that all animals experience stress in their own way, from mice to macaques. And it can range from pain, stress, and distress and depression and anxiety. And all of these cause changes within the mental and physical health of the animal simply by being placed within a laboratory. And those psychological effects can even include self-harm, obsessive compulsive behavior. It can cause severe changes to the immune system, metabolism, and also being more vulnerable to illness. So what you're seeing is not a replica of how it's going to work within us as humans. You can see that some of these effects can potentially be passed down through generations. So, for example, macaques who are wild caught or have experienced the stress and duress of laboratory life can pass on these genetic changes, causing an altered biology in their infants. So we're already looking at a completely imperfect system. But as we go on through the stages of life and through breeding, that altered biology is nowhere near looking like what we'd even want. So it's going to completely influence the reliability of that scientific data that we're getting. So beyond ethical concerns, there's a fundamental scientific flaw in using animals to model human disease. It all begs the question, if animals in labs are so biologically altered by stress alone, how can we rely on the data that they produce to accurately predict human responses? And the assumption that they are good models, and I don't even like to use the word model anymore, it's so flawed from the very beginning. We need to be investing in human relevant methods rather than clinging on to what we've all been taught from a very early age.
Just to take it in the direction of something that feels a bit more tangible for the listeners, we were thinking to maybe talk a little bit about a recent drug. And I think the one that most people would be familiar with would be semaglutide, which is known as Ozempic or Wegovy. It was specifically developed to treat type 2 diabetes, and it's been very effective. And it's also known to help people lose weight. So we've got some really good outcomes from the development of this drug. But can you talk us through the testing process and perhaps inform us over what sort of time period that would have occurred, how animals would have been used, at what stage, and whether any of that could have been avoided under the current regulations?
Right, absolutely.
That's a massive question.
Yeah,
Sorry.
it is a massive question. I mean, Ozempic is a hugely well-known drug, so yeah, I completely understand. It's probably a more tangible one for our listeners. It's probably worth people understanding that drug development at the moment is, from discovery all the way through to market approval, is a very long process, typically taking over 10 to 15 years. And you start off with this preclinical testing. So the drug is tested within laboratory-based studies on animals to test biological activity, safety, etc. Then it goes through a period of clinical trials. So the drug progresses through to human trials. So it's firstly tested the safety in small groups of healthy volunteers. Then we move on to evaluating the effectiveness in patients with the condition. So it's as it was originally marketed for people with type 2 diabetes, we would have evaluated the effectiveness at treating type 2 diabetes. And then it moves on to large scale trials to confirm the benefits, monitor the side effects. And then finally, we have agencies like the FDA and the MHRA to assess the data before granting approval. So yeah, long process, 10 to 15 years. And Ozempic followed this traditional pathway, so meaning that over a decade of research was required before it became widely available. Okay, so the next part you asked me about the animals used. Okay, so the process, as I mentioned at the beginning, preclinical trials. So the drugs were tested on animals before humans could begin. And in the case of Ozempic, they used mice and rats, and they used long-tailed macaques. For drug testing, there's always this two species that are needed, at least two species. They'll use mice and rats, they'll move on to a larger animal. And what we need to firstly remember that humans are not, 70 kilogram mice or 70 kilogram rats. How we absorb the drug, distribute the drug, metabolize and excrete it is going to be hugely different. Mice and rats, we first are used to identify the pharmacokinetics, so how the drug is absorbed, distributed, metabolized, and excreted, and how it affects glucose regulation. And then the macaques were used for long-term toxicity studies, as they're often considered as the closest physiological model to humans. But remember, these animals have endured, as I've mentioned repeatedly, stressful lab conditions, repeated dosing, invasive procedures, all to determine if the drug might be safe for humans. You asked me, can we replace these animal tests? Absolutely. And in many ways, we actually have the technology to do so. We have, I mentioned at the beginning, organ on a chip technology. A liver, kidney, pancreas, and brain organ on chips can mimic how Ozempic moves through the body. And as I mentioned to you earlier, Daisy, about how we need to be able to look at mechanistic data, how it moves through the body and how it affects different organs and get accurate results from it. Now, instead of using animal pancreas cells, we could use human stem cell derived beta cells. So the cells that are producing our insulin, we can derive that from human stem cells by providing it the right growth factors and encouraging it to grow into the cells that we want. And we can test the drug directly on these human-derived insulin-producing cells. Another way we can look at it is AI and computer models. Now, AI-powered simulations can predict how a drug's going to behave in a human body, replacing completely the need for primate testing, because if we have these AI powered simulations, we know how a drug's going to behave in the human body. We have that data already available to train a system. I probably should have mentioned earlier that actually we can connect multiple organ models. So such as I mentioned earlier, liver, gut, pancreas. So say if it's a drug that's orally absorbed, you might want a gut on a chip. You've got your liver, gut, pancreas, and we can then study how a drug works holistically using human relevant biology, something that animals can't replicate. We can't understand how a drug's going to work holistically in a human being through using an animal. Finally, you mentioned about regulatory agencies. So regulatory agencies still require animal data in many cases, even though there are newer methods, completely animal free, that are scientifically valid and ethically sound. And the FDA Modernization Act, which is we now have 3.0, was originally introduced in 2022. It's pushing forward this massive shift, allowing drug developers to use non-animal methods instead of animal tests. As long as we can validate it, we can use that instead of traditional animal testing. And it is a crucial step towards changing these outdated regulations. And so if the FDA in the US is pushing forwards, so should the rest of us. If drug companies fully embrace these technologies, a drug like Ozempic could have been developed without harming a single animal. And that's the future that we need to push for, where science is both ethical and truly designed for human health.
You've mentioned the FDA in particular. Some of our listeners will be in the States, but a lot of people will be in the UK. So I'm sure that there are differences between what's happening in the UK at the moment and what's happening on a European level. So it's a difficult question. But looking at the current legislation, is there anything under consideration at the moment to change our use of animals in research in Europe, in the UK? Because we're just wondering if there's anywhere where people can focus their efforts, or if they're involved in science that they really need to know about.
Prior to our most recent election, the UK Labour government pledged, and I quote, to partner with scientists, industry and civil society as we work towards the phasing out of animal testing. It's one sentence that we have from the Labour government. That commitment is significant, but remember, promises mean little if we don't have action. It's very important for campaigners to hold them accountable and push for real change. Phasing out is not nearly enough. And actually, in the last few weeks, we've had in Parliament, we had 12 questions written into the government from our MPs about animal testing itself, whether it's speaking about specific facilities such as the beagle breeding facility in Cambridgeshire, or whether it's about asking the Labour government, okay, you have put in plans, you've put this one sentence, what are you going to do about it? So phasing out is not enough. Our MPs are now speaking up for us, and people are more aware about this topic than ever before. And we need to demand a clear timeline for ending animal testing altogether. If I had my way, it'd be done tomorrow. It'd be done today. What we need to do is we need to end the import and the breeding of animals for experiments. And it's a major driver of the continued reliance of outdated methods. We continually breed and import animals. It continues the cycle of this torture, and we need to end that in the first instance. And we need to be able to redirect all the funding from animal research into human relevant, animal free research. And so the innovation is not held back by that reliance on flawed models. The animals that we have that are currently undergoing the stress of laboratory life, we need to ensure that they have suffered enough and are given a chance at a peaceful life. So we need to think about rehoming these laboratory animals as well. So sorry, I feel like I gave you my manifesto there, but I'm just telling you that Labour have put in that one sentence, and now we need action.
So thinking about the fact that there will be people who have got commercial interests in using animals, and so who will not be voting to end animal testing. But thinking about within the science field itself, are there still a lot of opponents to ending animal testing? Are there still, because I'm thinking about, I think it was not that long ago that I saw a piece in the British Medical Journal. And, there's possibly on one side, there was the person saying this is why we need to use animals. And on the other side saying, no, we don't, we need to move on to these new technologies. Are there people like you, but working on the other side?
Okay, so you're asking whether there's campaigners. There most certainly are people who are invested in animal research and testing. And we started this at the beginning talking about my career, and actually the way in which we educate really, and if you've done anything science related, it just seeps in that you are just told right at the beginning about animals being some sort of necessary evil. And the more I understood the science, the more I realized this is completely and fundamentally wrong. But there are people who are built into the system that keep that narrative running, either because they have money invested in it, or they haven't been able to see the light itself. Now, there are many different opponents out there, whether it's universities that might have partnerships with particular companies. And I don't know if you know Understanding Animal Research, it's an organization. They are actually funded by the very industries that use animal testing. They're there to be the kind of the spokesperson for animal research and why we still need it. And I also think that organizations such as the NC3Rs, the National Centre for Reduction, Replacement and Refinement, we have this narrative. It really is within the UK specifically that if we reduce the number of animals, then we're fine. We've done our best. If we try and refine it so the animals don't suffer so much, it's fine. We can get by. But we have continued that narrative that we are reducing it. And so actually replacement doesn't get a word in. Replacement's still there. And they did a review not too long ago when they found that replacement doesn't get hardly enough money that it's supposed to. It's quite insidious in some ways that you have centres that focus by saying we are reducing, we're refining, but they're not tackling the problem head on. And we need to look at how we can have 1R replacement. And so, yeah, it's an interesting question. It's opponents in the sense of we haven't quite understood why we need to completely replace.
I suppose I'm thinking, Savita, I'm thinking specifically about something like neuroscience, where it's almost a rite of passage that you have to have, and using monkeys and, looking at looking at using monkeys to train people to be neuroscientists going forwards. And people write about how unpleasant that part of their training is, but it's very difficult to avoid it. And as you say, talking about your own career, be credible, getting positions further down the line if you haven't done that. So I wondered whether there's almost like sort of lobbyists within neuroscience saying, you know, we need to defend our right to continue to use animals.
There's lobbyists in general. So I mentioned that there are companies such as Understanding Animal Research, and there are centres such as the National Centre for 3Rs as well, because the narrative of 3Rs itself is quite damaging, because it begs the question that if we're reducing, we're still pushing the science forwards, but we're not. And I think neuroscientists probably have the similar situation where if they think that they're reducing the number of animals, it doesn't make the procedure that they're doing scientifically or ethically sound at all. And yeah, I do understand when it comes to credibility comes from the education, and credibility comes from following the science. That's why I wanted to work in education. If we can change how we train our future scientists, future medical professionals, we can encourage them to look towards what's popular today, non-animal methods, what is cutting edge, what is actually providing reliable and accurate results. And that is non-animal methods. I was 3 months into my PhD and I left it because I started to get asked about animal testing. I thought, this is not what I want to go into. And there are definitely ways around it. And there are many organizations such as myself that are providing animal-free PhDs and programs where you do not have to harm a single animal. So that there are ways out there, and that needs to be maximized, and the money needs to be put in there. So yes, not as straightforward as I like, but that's where we are. That's the climate of today.
Unfortunately, it's never as straightforward as we like, but there's so many parallels to this conversation and sort of, I guess, eating animals, because, it's that whole thing. Actually, it's not necessary. We don't need to do, and it's probably not good for us, and there's better ways. And it's like you say, just shifting that dial a bit, isn't it? And helping more people understand that. But this brings me back to how people can connect with you. If, for example, someone's listening and is really inspired by what you've just been telling us, Savita, and doesn't want to wait for government to finally action something, what can people do? How can they contact you? How can they work with you?
Oh, that's great. Thank you. And I appreciate, I think there's a lot of parallels between any form of activism when it comes to using animals, being able to stop thinking about using animals as a tool or a means to an end, and actually being able to say to ourselves that we live on the planet with animals. How can we treat them with respect and kindness? And that's the fundamental point of Medicine Without Cruelty. If you want to drive real change, everyone has a role to play, and that's why I founded MWC. The mission is to push for an end to animal testing by promoting human-relevant, cruelty-free research. And you can get involved if you are an educator. We provide resources to help you integrate non-animal methods into your teaching. Get in touch if you'd like to collaborate. We want to work with you, want to provide lesson plans, etc. If students want to advocate for humane science in their institution, we can support you by pushing for policy change. Organizations, we really want to partner with us to sponsor curriculum development, outreach programs, and campaigns that promote ethical, cutting-edge science. And everyone can follow Medicine Without Cruelty on social media, medicinewithoutcruelty.com. Spread the word and join the movement to completely remove animal testing entirely. So please do contact me directly. You can even drop me a line on social media if you like.
That's absolutely brilliant. Thank you for all the work that you're doing. We're really inspired, and we really hope that we can bring you back in a few years and talk about all the successes that Medicine Without Cruelty has had. But we know you're very busy and you've got a lot to do in both your roles. So what does a busy scientist, I suppose, have for their dinner on a Wednesday night?
The best kind of dinner. I've got leftovers.
Oh, very good. Yeah.
I mean, you can tell from the name that I'm Indian, but I've got like lentils, dal waiting for me, which is perfect because it's comforting. It's protein, and of course, it's completely cruelty free. So it's just like I advocate for medicine without cruelty. I like food without cruelty too. So,
Lovely.
what about you guys? What's on the menu tonight?
Well, I was going to say dal always tastes better left over, doesn't it, the next night?
It
I wish I
does.
had a bit of that. What about you, Claire? What are you having?
Well, I'm having a very un-Indian meal, I'm afraid, because I do love things like dal. But tonight, I've got quite confident making seitan sausages.
Oh,
And you
right.
can make them in different flavors. And of course, it's using vital wheat gluten and mixing it with some stock and some herbs. Sometimes you can sort of blend a beetroot in there to give them a bit of color. And then you just shape them into a sausage shape and drop them in a pan of water. And if you want to, you can sort of dry fry them off. And I'm having that on a big bed of mashed potato. And I've got a Savoy cabbage as well to have with that. Probably have some onion gravy as well. So it's quite an old-fashioned dinner, but it's
Nice, though.
really,
Sounds good.
yeah, it should be really, really healthy though on this sort of funny weather going between winter and spring, isn't it? So,
But, I keep thinking I need to make seitan because I've not made seitan in a long time. It's just one of those things. I keep thinking I need to make more seitan.
it's really easy if you've got that wheat gluten. Have you made it, Savita?
No, I've never made it for. I think I end up buying a lot of packaged stuff when it comes to when it comes to seitan. So I've never tried to
It's
make
better
it
when you make it, isn't it? I find it's it obviously is homemade often tastes better, but it doesn't take very long. It's just getting organized. That's my problem.
It's really well, okay. So you're not organized. So what's the chaos of your dinner tonight, Daisy?
Yeah, the chaos will be a stir fry. That's my Wednesday night, very quick. And I don't like those pre-packaged bags of vegetables either. So I'll just use whatever I've got. So there might be like half a head of broccoli left over or, carrot. Everything gets chopped up really, really small. So I make my own sort of stir fry mix and tofu usually. But I do have a good tip for a peanut sauce that can go on it, which is just a dollop of peanut butter or any nut butter or tahini if you've got a nut allergy, soy sauce and agave, and maybe a little bit of, so you need a sour, so you need something like a rice wine vinegar or a lime juice. It's a really easy, quick and easy stir fry sauce.
Oh, nice. Thank you.
So that'll be my dinner.
Great.
It's quite nice. Yeah, throw it together.
On that note, I think everyone's very hungry, so we will want to say a very big thank you again, Savita, for your time, and we really enjoyed chatting with you today, and we really hope to have you back on the podcast as well in the future.
Thank you.
Oh, it was lovely to speak to you both, and thank you.